as per code. Sorry. As per code with suitable examples. Narrate the design requirements. Next question. Narrate the design requirements from NBC. Narrate, N-A-R-R-A-T-E. The design requirements from NBC. Narrate the design requirements from NBC for the design of timber joists. For the design of timber joist. Next question. Compare and contrast steel structures and timber structures. Compare and contrast steel structures and timber structures. Explain how, next question, explain how timbers are grouped and on what basis. Explain how timbers are grouped and on what basis. Next, importance of seasoning of timber. Importance of seasoning of timber. Next question. Draw a neat diagram. Draw a neat diagram of Madras terrace roof. Draw a neat diagram of Madras terrace roof and mark the pots. Draw a neat diagram of Madras terrace roof and mark the paths. Next, compare the timber structures, merits and demerits with other types of construction. Compare the timber structures, merits and demerits with other types of construction. With other types of construction. Next question. Explain about Madras terrace roof. Explain about Madras terrace roof. Next question. Importance and grouping of grading of timber. Importance and grouping of grading of timber. How many questions? 12. Okay, leave one more page for that. If I find any other important questions, previous year university questions, we'll add on to it. Fine. Did you find any problem in that? Any sums? No, it's full of theory. As for now, whatever I found, it's full of theory and not problems. And there are few problems which I'll find out and let you know later. Fine, we'll start the class. And there are few problems about timber columns and timber beams. Okay, we'll study that also, and I'll let you know the problems also. We'll start the class now. Yes, this is the first class. Okay, let's discuss about wood. What do you know about wood? We already discussed, right? Where are we using it? Furnitures. It's wood. We use wood is one of the building material, right? Yes, we using it for building construction. And what else we know about wood? We know wood is mainly used for what? In construction. It is used for temporary structures, for shuttering, for scaffolding. You know about shuttering and scaffolding? Framework, where you put the concrete in and you leave it for what? Few days for curing and to make the concrete harden in a correct shape. For that we use timber. We use wood, right? Have you seen that? So those are temporary structures. And we have seen few other timber houses, right? Have you seen timber structures, timber woods? Yes. And we can easily dismantle it, right? Timber structures. And for permanent structures, where are we using it? Timbers, roof, flooring, for the windows, rafters, purlins, and lot of stuffs. Yes. And there are two defects in timber. Note on that. Defects of timber. Natural defects and other defects. Have you heard about knots? What do you know about knots? Knots are the place where? Yeah, natural defects and other defects. Under the topic of natural defects, we are discussing about knots. Knots is a natural defects. I'll let you know. So what about knots? When a branch or a limb is embedded in a body, and when there is a tree cut, and there the knot is formed. I'll say again, in a branch, okay, when a tree is cut, okay, there knot is formed. And how knot is formed? When tree is not exposed to sunlight. In those places knot is formed. And what else about knot? Do you know anything else about knot? I heard somebody saying something about knot there. To destroy? It affects the tree from inside. Bark, it's something else. Yeah, inside the annual rings. Okay, note on when the portion of a branch or limb embedded in the body of a tree, when the portion of a branch or a limb, when the portion of a branch or a limb L-I-M-B, embedded, E-M-B-E-D-D-E-D, embedded in the body of a tree is cut, then knot is formed. In the body of a tree is cut, then knot is formed. Sometimes, note down, sometimes lower branches of a tree die and fall down. Lower branches of a tree die and fall down because of insufficient supply of sunlight. Sometimes lower branches of a tree die and fall down because of insufficient supply of sunlight. As a result of this, knot is formed. So how knot is formed? Read it and say me. How knot is formed? Yes. And how knot is formed? Somebody else from here. Are you clear with knot? No? No? How do I explain? See, let's take the lower branch of a tree. Yes? And if the sunlight doesn't fall on it, what will happen? How will it affect the tree? The branch will dry. And what will happen? When the branch falls, what will happen to the thing? Cavity will form. And when the tree is not exposed to sunlight, and we know there is water in the tree, right? Yes or no? Do you know that there are a lot of cells in the tree? Huh? What? Be louder. And due to that, the knot is formed. Okay? Maybe we'll watch a video how knot is formed. I have a video. I'll bring that. Okay? So we'll go to the next thing. Vein. Okay. Another thing which I want to explain is, if knot is formed, what will happen to the timber? It will reduce what? Strength. Okay? See, a basic thing about structure I am explaining you. Please listen now. Let's take a beam. Let's take a rectangular beam. Yes? So when a load acts here, what happens? See, in a structure there are two zones. In a rectangular beam there are two zones. One is the compression zone. This part is the compression zone. And this part is a tension zone. How do you say this is a compression and this is a tension? The load is directly acting over here. So what happens to that part? It gets compressed like this, right? And what happens to the bottom part? It expands. So this part is a tension zone and this part is a compression zone. It is compressed, right? Yes or no? So due to that, what happens is these two zones are affected when knot is formed. Clear? I'll clearly explain about RCC later. When you take a rectangular beam, this tension zone has to resist the load, right? It should not come down like this. It should not sag. It should not bow like this. And this part has to resist the load. And these two zones are affected when knot is formed. Clear? Note on that. The strength of the timber is reduced when the knots are situated in the bottom of the beam. The strength of beam is reduced when the knots are situated in the bottom of the beam. When the knots are situated in the bottom of the beam, what happens? It reduces the strength. But if the same way, if the knot is situated on the top of a beam, the weakening part is very less. It doesn't reduce the strength much. It reduces only little. But when the knot is formed in the bottom of the beam, that is in the tension zone, it reduces the strength of the beam. It weakens the beam. Yes, because of the tension zone. But in the compression zone, it doesn't affect that. Because at the tension zone, see, it is weak in the tension zone, but it's good in the compression zone. And that's the reason, if the knot is formed in the tension zone, it reduces the strength. Clear? What did I say now? It is weak in where? In the bottom. So when knot is formed in the bottom zone, that is in the tension zone, what happens? It weakens and it reduces the strength. But it forms in the top of the beam, the weakening is less. Do you want to note on that point also? When the knots are situated near the top of the beam, when the knots are situated in the top of the beam, in bracket write the portion of beam in compression, the portion of beam in compression, then it has less weakening effects. Then it has less weakening effects. You want me to repeat that point again? When the knots are situated near the top of a beam, okay, in bracket write the portion of beam in compression, then it has less weakening effects. The strength of timber, this is important point, the strength of timber is considerably decreased in tension because of knots. The strength of timber is considerably decreased in tension because of knots. Because of knots. Next point, the strength of timber reduces to a small extent. The strength of timber reduces to a small extent in compression because of knots. Timber reduces to a small extent in compression because of knots. The last point again. The strength of timber reduces to a small extent in compression because of knots. Next natural defects is about vein. See, vein is a lack of wood at the corners or at the edges of a wood. Vein, listen, vein is a bark of lack of wood at the corners or at the edges. Lack of wood at the corners or at the edges is called vein. It's all natural effects. Huh? Bark, lack of wood at the corners or edges. So it reduces the strength. So for that reason, what we need to do, we need to cut down this part and make it a square. We know that vein reduces the strength of a timber. So for that reason, we need to cut down these things and make it as another shape and make it a square. And when we neglect this part, and we have good strength in this region. Are you clear? You want me to explain this again? See, let's take a rectangular wood. Okay, when there is lack of wood, when there is no wood, when this part of wood is gone, okay, when this part of wood is gone, it reduces the strength, and that natural effect is called vein. Okay, so in order to increase its strength, okay, let's cut this part and make it as this square thing as a timber portion. And when we use this timber portion, we'll have good strength. But when we use this portion as a whole structure member, the strength is very less. Clear? If you properly square wedge, then we can increase the strength. You clear with knot and vein? What do you mean by knot? How knots are formed? Absence of sunlight. And when there is a cut in the tree, okay, where? When a branch falls or a limb falls, and we find a knot over there. Okay. And what about vein? Lack of wood at the edges. And how do you overcome that? Squaring the edges properly. What if vein is there in the timber? It affects the strength. What do you mean by strength? Strong. The other way you say strength, explain about strength is strong. To carry something, to bear the load. The ability to carry something. You are clear with the natural defects? Yes, we proceed. What about artificial? Huh? The other defects are warping. WAR. You need the notes for vein. A vein is a bark of lack of wood. A vein is a bark of lack of wood on the edge or corner of a piece of a timber. A vein is a bark of lack of wood on the edge or corner of a piece of a timber. You clear? I'll proceed. Vein affects the strength of a timber member. Vein affects the strength of a timber member. Vein affects the strength of a timber member only because the cross-sectional area is reduced. It can be avoided by properly squaring the edge. We'll proceed for the other effects. And what do you mean by warping? What do you mean by warping? Bending. What do you mean by warping? When you affect the shape, when you try to alter something, right? So there affects warping. Okay, that causes warping. When you try to change in the shape, when you alter something, when there is a permanent distortion. What do you mean by distortion? Change. What do you mean by distortion? What is the meaning of distortion? Alteration. Change in the shape, right? And that causes warping. And warping includes three things: cupping, bowing, and one more thing, twisting. How warping is caused? Warping is caused by permanent distortion. That is, when there is a permanent alteration in the structure, when you change the timber shape, and that causes warping. And warping includes three things. One is that cupping, bowing, and twisting. Let's discuss about what is cupping, bowing, and twisting. Yes? What do you mean by bowing? Bowing. Other term for bowing, can we call it as sagging? Bending. And due to distortion, listen carefully, due to distortion, and when there happens a bowing, okay, from one side to the other side, and that is called bowing. Due to distortion, okay, what do you mean by distortion? Change, alteration, okay, when you change, when there is a change, due to that, changes from one state to the other state, okay, and there happens a sagging, and that is called bowing. Have you seen a bow? Have you seen the shape of a bow? How is that? Kind of curved? Yes, the same way, that is called bowing here. You want to write a sentence for bowing? No down? You want warping? Okay. Warping is caused as a result of permanent distortion of timber. Warping is caused as a result of permanent distortion of timber. If you find difficult that for the word distortion, write somewhere about distortion is alteration. Warping is caused as a result of permanent distortion of timber. Clear? And for bowing, write down. When the warping takes place in the form of sagging from one end to the other end, okay, from one end, takes place in the form of sagging, from one end to the other along the longitudinal direction. So which is the longitudinal direction? This is the longitudinal. Longitudinal how? When there is a change in this, okay, when there happens a sagging, right? It was like this. This was the original, original shape. And when there is a change here, that in the longitudinal direction, that happens bowing. From one end to the other along the longitudinal direction, then it is known as bowing. And note down for cupping, when the warping takes place in the width of a when the warping takes place across the width of a timber board, then it is known as cupping. Across the width of a timber board, then it is known as cupping. What do you mean by spiral? Twisting. When the warping takes place in the spiral form in the longitudinal direction, then it is called twisting. You want me to tell me that when the warping takes place in the spiral form in a longitudinal direction, then it is known as twisting. You're clear with cupping, twisting and bowing? You're clear with warping? What do you mean by warping? What do you mean by warping? Permanent alteration or permanent distortion caused in the timber. That is called warping. What do you mean by bowing? Sagging from one side to the other is known as due to what? Due to distortion. And what do you mean by cupping? What happens there? Which one? No. What do you mean by cupping? It affects the width of a timber. And what about twisting? Spiral form in the longitudinal direction. You're clear with that? And let's discuss about the next defect, next rupture of tissues. Even the rupture of tissues is caused because of the permanent distortion. The same reason. What happens for warping? The same reason for distortion. The rupture of tissues takes place as a result of permanent distortion of timber. You want me to say that? The rupture of tissues? Yes, this is another type of defect. Other type of defect. Permanent distortion of timber. There are three things in that: shake, split. I'll explain that also. It includes checks, shakes, splits. Checks, shakes and splits. Yes. No. Distortion is what? Warping. The same thing, yeah. Rupture of tissues is also due to permanent distortion. Sorry? No. Not is different, and these are the other defects. And that happens naturally. And see, we can say these things as an artificial defects. We do something to change its shape. We do something, right? with the timber, and due to that reason these defects occurs. These are artificial, and not in vain are natural. Without we doing anything, it happens naturally. But other defects like what? Warping and this rupture of tissues, it happens due to when we do something to the timber. Let's discuss about checks. What do you mean by checks? A check is a crack or a lengthwise separation of timber. Checks is a crack or a lengthwise separation of a timber. Say it again. When? No. I'll tell you how crack happens here. During drying, listen. During drying process, from outside to inside. Okay. During drying, what happens? It what happens? It takes the water from the timber. If you take the water from the timber, will it affect the shape of the timber? It will shrink. When it shrinks, it causes cracks. When it is more dried, it causes cracks. Not about shake. Not on about shake. Shake is separation along the grains of the timber. Shake is separation along the grains of the timber. A shake is separation along the grains of the timber. Have you seen the grains of the timber on the surface? Different lines. Yes. And another thing about shake is shakes does not develop due to drying. Yes, but it happens due to felling of tree. Note down, the shakes do not develop because of drying. The shakes do not develop because of drying. The shakes originate because of careless felling. The shakes originate because of careless felling. See, when the living tree is felled, what happens is the internal stresses are developed inside, and due to that, what happens? It forms shakes. Note down, when the living tree is felled, when the living trees are felled, the internal stresses are released, which result in separation along the grains, result in separation along the grains. And that causes separation in the grains. Next class, remind me to show the knots, okay, and grains also. Split, not on about split. Split is a separation of timber which extends from one face to the other. Split is a separation of timber which extends from one face to the other. which extends from one face to the other. And when it occurs at the end, it is called end split. And when it is occurs at the end, it's called end split. And when it occurs at the end, it's called end split. Okay, wait, done with the defects of timber. What are the defects of timber? Natural and other defects. Other defects is an artificial defects. What about natural defects? Warping, sorry, knots and vein. What about other defects? Warping. In warping, what is included? Cupping, twisting, bowing. What about rupture of tissues, shakes, splits, checks? You're clear with that? You're clear with the defects? We'll proceed. You know the basics about wood. Wood is used where? It is used. It is mainly used as a temporary structure. In permanent structures, where are we using it? Rafters. Yes. In temporary structures, where are we using it? For shuttering, scaffolding, frameworks, formworks. And what about permanent structures? Where are we using it? And what is the advantage of using timber, Donna? Sleeping. We can easily dismantle it and we can use it in some other place. And if the timber is maintained well, okay, the life of the timber structure is more. Okay, if you keep it dry, you need to keep it dry. If you keep it wet, you need to keep it wet. That's a good maintenance. But when you expose the timber for alternative of drying and wetting, the strength is gone and you cannot use the timber anywhere else. Either you dry it, either you wet it properly. If that process is maintained well, the life of the timber is more. Clear? You want me to explain this again? If timber is maintained well, the lifespan of timber will be more. Okay, either you keep it in the wet condition or either you dry it. But when you do it an alternative like drying and wetting and drying and wetting, it will affect the strength of the timber and you cannot use it for a very long time. Done? We'll go to the next topic, seasoning of timber. Go to the questions which I gave you. The seasoning of timber is asked. Yes? Seasoning of timber is asked. So we got to learn about seasoning. How many of you know that wood has a lot of cells inside? There are a lot of water cells in it. Okay? The water helps the tree to grow. How do tree contain water? The roots absorb water and the waters come up, so there are waters inside. Yes? So, and for the people who doesn't know about there are cells inside, I'm telling you today there are a lot of cells inside. Clear? And tree is a hygroscopic material. How many of you know about hygroscopic? What do you mean by hygroscopic? The ability to absorb water. Yes? So why do we need to do seasoning? What do you mean by seasoning? Okay, see, listen. See, there are a lot of trees there. Okay, we are going and cutting a tree and we are bringing it here, and I am giving you an assignment of making a table or chair. Will you be able to make it with that immediately after you cut down the tree? Okay, even if you make it, will the life of the wood in the bench or chair, will it be more? No. What will affect? Since there is water content inside, see, let's take a tree. If there is water content inside, moisture helps the other bacteria and organisms to grow inside, which will affect the timber. Let's take a sponge. Have you seen sponge? Yes. When you immerse it with water, what will happen? It will absorb water. When you squeeze it, it comes out. Okay, when you immerse with water, what will be the weight of the sponge? Weight of sponge plus water, it will be more. It will be quite heavy, right? But when you squeeze it, the weight of the sponge will be reduced. It will be very less. Similarly, here we need to remove the moisture content, that is water from the timber, that is from the wood. Okay, the seasoned wood is called timber. The seasoned wood is called timber. Just nothing like when you take a wood and you cannot call it as a timber. Note down for the timber. When the wood is used as a structural material, it is called timber. Note down somewhere in the beginning of the notes. Timber structures. When the wood is used as a structural material, it is called as timber. When the wood is used as a structural member, it is called as timber. So here seasoning is removing or drying of water from the tree, and that process is called seasoning. Removing or drying of water from the tree is called as seasoning. Clear? In seasoning there are two processes. The same way, one is natural. Seasoning is what? Seasoning of timber is removing or drying of removing of water or drying the wood is called as seasoning. And there are two methods of seasoning. One is artificial and another is natural. And see, listen, if water is contained in the wood, in the timber, it cannot be used anywhere. It is waste because the strength will be less. You know about strength, the ability to carry something, it needs to be strong, right? To say a good example about that, let's take a very fat man like me who has a lot of water content in, and let's take a very lean person who's very strong, who goes to gym and he's very strong, and comparing to both of them, who's strong? Comparing to both of them, who's strong? The person who's very lean and who's very strong, and not the person who's very fat with a lot of water content in it. Yes or no? The person who's very lean and who's very strong, he'll be able to run fast and work fast. But the person who's very fat and who has a lot of water content in his body, he cannot run or walk fast. Yes or no? The same way here, if we have water content inside the wood wood cannot be used for any other purpose, because the strength of wood will be very less. For that reason, to increase its strength, to use the wood for various purposes, we need to remove the moisture content from the wood, and that process is called seasoning. So seasoning is important. Clear? There are two processes, one is natural and artificial. How do you remove the water naturally? Drying. How? See, both the things are drying. Artificial also, you are removing water from that. Sun dry. And when you expose to sun, what will happen? It absorbs water, good. And when you expose the wood to more of sun, what happens? It absorbs water. After water is removed from that, what will happen to the wood? After water is removed, it shrinks and it develops cracks. For that reason here, to avoid cracks, we need to expose for air, and that process is called air drying. Air drying. Natural process is air drying, not sun drying. Okay, how do you expose only to air, not to sun? Closed all four sides. Then only the top portion, only the roof is covered. What about the walls? On all the four sides it is opened. And when you keep inside, when you allow the air to what? Flow through it from one side to the other side, what happens? It goes in, and when it comes out, it removes water from that. And you people, you dry the clothes in your hostel, right? When there is heavy rain outside, you keep inside your room, you open the windows, you try to what? Live with the air too. Have you seen people traveling like in the bus? They used to put their kerchiefs outside and they expose for only for air, right? When you expose any material to air, when it passes, it removes moisture. So we need to remove what? Moisture content from the timber. So that is done naturally by air drying. So for that process, what you do is, I'm not very good in drawing, like you people. You just keep a roof covered, but on all the four sides it will be opened, right? I don't know to draw properly. I can do it only in CAD, but not you, like you people in hand. You'll have columns. Those columns are concrete columns. And you'll have a concrete base. Sneha, nice sleeping, no? And you have, see, I'll explain this alone. Have you heard about stacks or stick piles? See, lot of sticks are kept in between to keep a distance between the timbers, to give a good space. When you give a good space, when you don't attach each wood together, what will happen? Air circulation will be fine. When it is very close to each other and when you don't give space to each other, what happens? The air cannot move inside, and you cannot remove water from moisture content from all the sides of the wood. Clear?